Hello. Well, I hope everybody's doing well and staying well, healthy through all the COVID stuff. I'm doing this video, it's going to get you started on your at-home lab projects, okay? So I'm going to be talking about the parts and pieces and different criteria that goes with them. If you get on the job, if you know something about the parts and pieces and you can go to the storeroom and get the parts, you just scored points with all the old electricians, okay? So, we're gonna get started. Now, first off, you have your board, it's a 4-foot board. We're gonna be mounting our boxes. These boxes are 4 inches by 4 inches by 1.5 inches deep. They come in different depths, okay? And this here, if you measure it, 1.5 inches on the inside. Now it also has different size holes. The holes are 1/2 inch on the small ones, 3/4 inch trade size. If you measure it, it's not going to measure 1/2 inch, not going to measure 3/4. But we use trade sizes in electrical, and these are 1/2 inch Romex connectors or NMC connectors. So since we have both 3/4 and 1/2 inch knockouts in these, and these are knockouts, or KOs, KNOC, KOUTS. And those holes are where you install the connectors. So this is a 4 square, okay, 4 by 4, 4 square 1.5 inch deep metal box with combination knockouts. If you say that, you're going to get this exact box. A 4 square with combo knockouts. Now, we're going to mount this to the board. So the first one we start with, you want it on the end of the board, and you want to square it up, okay? You don't want your boxes like this or like this. You want it in the middle of the board, you know, within reason, and square with the end and square with the sides. And how you do this is you can eyeball it. You can put it on the very end, eyeball it to get it in the center, and then use straight edges. When you run conduit or when you build panels, train your eye to use a straight edge. So I'm taking the straight edge of the top of this box, and I'm coming down, and I am lining it up with the straight edge of the board. So if you do that and get both those lines parallel, okay, just go back and forth till they line up. Then you know you have your box square. Now on the very end, you can square it up with the very end, but as you move on down through here, you'll want to use the parallel lines on the side, okay? Now I'm going to use a drill. And if you've got a 9-in-1 screwdriver, you can just pull the bit out and chuck it up in your screwdriver if you don't have a bit. And there you go. So I've got this first one lined up pretty good. I'm going to put the first screw in. Now the box moved a little bit, so I'm going to get down here. I'm going to line it up again. And you know what? You can't put a price on caring. If you don't care enough to put this on straight, I can't help you, you know? But if you get on the job and you swap the work around, you're going to build a reputation for yourself. It takes very little more time to make things square and do things neatly. And I worked for some pretty hard cases during my life, and they demanded good work. And I'm glad they did, because it's just a habit now. If you make yourself do it, it's a habit, you don't even think about it, okay? So, got it lined up straight. Now if you look at this, okay, it's in the center, just about here, and it's square with the end, okay? It looks very neat. And neatness counts on a job. It's called a workmanlike manner by your electrical code, okay? So you want to do work in a workmanlike manner. Now, what we're gonna do is put the next one on there. I've already measured, so one thing you wanna always have with you is a pencil, okay? So, another lesson here. I know you might be in the habit of packing an ink pen. There's a lot of things I want in ink. I want my signature in ink, notes in ink most of the time. Doesn't matter on that much, but in ink. But if you're doing electrical work, you want a pencil or a mechanical pencil. Because if you start marking up your blueprints with ink, I tell you, the electricians are going to be all over you, all right? If you do it in pencil, you can erase it if you make a mistake. I made a career out of mistakes. I had to erase stuff all the time. I'm glad these things come with two erasers. I use them both, you know? So, use a pencil, use a pencil, use a pencil whenever you're doing prints or electrical work, okay? Not many exceptions. Now, what we're gonna do, we're gonna measure from this side of the box to here, 10 inches. 10 inches, dead nuts on it, all right? Now, there's 10 inch, well, I moved it, okay? Moved it before I marked it. Okay. Now I marked this side of the box, marked 2 places. Now, if I move the box, I can still get it lined up, okay? So, I'm gonna get it pretty square. And I want you to send pictures to me on whether you got your box is square or not, because I'm gonna be judging you on it, okay? So. Okay, now, whenever you tighten that first one up, you're gonna move it a little bit, but look down through there, line it up again, line this edge with this edge, you'll be good. You'll be good, okay? You wanna put 2 screws in there. If you only put 1 screw in there, it's gonna move. You always want 2 screws. You wanna mount a box securely, because if you just put 1 screw in it, most of the time, sure there's exceptions, but not many. If you just put 1 screw in it, you can have everything plumb, it's straight up and down, level, straight across. You can have it looking great. And as soon as you walk off from it, if somebody nudges up against that conduit or that box, it's gonna cock it to one side because you only have 1 screw in it. Put 2 screws in it. I put 3 in them sometimes on jobs because I don't want it to move. Okay, same thing here. We're gonna go out 10 inches. Real easy, 10 inches, all right? So, there's 10 inches. I marked that side, so if I move it, now, I'm gonna split the difference, all right? And I'm gonna line it up with the edges, okay? So, now, I'm gonna line it up again, because probably moved a little bit. Now I'm always going to check it when I get through on these to make sure that it's still square. If it's not square, I'm going to take a screw out, square it up, put another screw in it, okay? And the next one's 10 inches, there we go. Right there. Hold it, line it up. Draw a little pencil mark on it so I know where it's at. Okay. Now I moved that, I trust you saw that. I'm gonna line it up again, okay? Now I'm gonna line it up again. It just doesn't take that much. And they're paying you $100,000 a year to do this stuff, so you might as well do it right, right? Or $60,000 or whatever it is, you know? Okay, now, look at that board. They all look nice and neat. They're all 10 inches in between them, okay? This end here has a little board hanging over it, about a couple, 3 inches. I did that on purpose, okay? This is where we're gonna put our plug-in cord, okay? So that's not our next step. I'll talk about that when we get there. We're gonna deal with these Romex connectors and the knockouts, okay? So, on knockouts, what you'll want to do, okay, is, I'll be right back, gotta get a box. Okay, I'm gonna get a little closer here. I'm gonna get a little closer and show you up close. These knockouts here, okay? You can press them with your finger and press them in. See how that went in? Now, I'm going to take these lineman pliers, grab that, and just twist it, and it comes out. Now, you got a 1/2 inch trade size hole, okay? Now, the other way, some of them don't push in with your fingers very well. You can hit it like that. That goes in they're called slugs. The slug goes in, you twist the slug, it comes out. Now, you got 2 holes. So that's how you take a knockout out. Now, I'm going to show you up close this Romex connector, okay? This Romex connector has a clamp on it, and that clamp is what's going to clamp our wire. This Romex connector has 2 pieces here. This is a lock nut. This lock nut has teeth on it. There's 2 different types. The ones we have in our kits have teeth on both sides, okay? You can see the little teeth. That is to tighten down tightly on this metal box. Here's your first lesson on grounding from me, okay? Every metal part that the public can come into contact with, either intentionally or accidentally, is required by the code to be bonded and grounded. This here, this little hump, is where we're going to bond this box to our grounds, okay? And I'll show you when we get there. But these teeth here, if you have a lock nut that only has teeth on one side, and you can tell because you can put it up against your hand, turn it around, and it's not going to grab, turn it the other way, and it's going to dig into your skin, okay? They're a cupped lock nut. These here, it doesn't matter which way you put them on. But the ones with teeth on one side, they have to go against, the teeth that dig in have to go against the box, okay? Now, we're gonna put this in here. The Romex connector goes with the screws on the outside of the box. And I'm tightening up the lock nut on the inside, okay? Now, this is really important. You want to hand tighten this, okay? And these boxes that have covers on them, they have to be what the code book calls accessible. In other words, you have to be able to get to that cover. You can't put this up inside finished drywall. You can't put it up inside a finished wood wall. You can't put it inside a block wall. Now you can recess it to where it's flush, okay? If this is the wall, you can put it where it's flush and you can get to the cover. But you have to get to a cover if it's made to be taken off. Now, having said that, sometimes we have to go back in and add wire. Now, we have to add wire, we have to get to these screws and unscrew them. So, you know, it's like, I used to work with a really good pool player, and he could tell me every shot he made, and he could tell you 4 shots, 5 shots ahead of where his cue ball was gonna be, okay? Good tradespeople are the same way. If you ever watch a carpenter, they're throwing little blocks to the side. They're saving piles of little scraps because they know they can use those scraps down the line, okay? Now, us electricians, we have to work smart too. We should work smart. Okay, so we know we might have to get those screws. If I leave those screws like that, okay, and I know I always have to be able to get to the front of that box, be accessible, doesn't it make more sense if I turn the heads of those screws to where I can get to them from the front? I think so, okay? So once you get that finger tight, take your lineman pliers, okay? Set your box down and just turn it just like you saw me do there, okay? See that? Now, that's lined up. No matter where that box is, I can get to it with a screwdriver, okay? I can get to both those screws. Life's easier, okay? Now, it's really tight. It's not loose. I hit that, you can't hear anything move. The teeth of that lock nut has dug into that box, okay? And now it's all bonded together, the connector and the box, okay? That's what we want. So I'm gonna go over here and put connectors in our boxes. Show you how quick it is, okay? So we're gonna use the center knockout right here, okay? And show you how quick all this stuff goes in. It doesn't take long. Okay, now I'm tightening this up and I've got the screws pointed toward you, but I'm going to take my linements and turn it to where they're straight up. Now I can take my screwdriver and I can get to all of them. Life's easy, okay? So I'm going to just knock one of them out on the end where that box is even with the end of your wood, okay? Now I'm going to go ahead here and push out all my knockouts, okay? Now, if I noticed on this one here, I turned the box, wasn't paying any attention, and I had it turned to where my 1/2 inch hole, my center hole is 3/4. We have 1/2 inch connectors here in your bag. So go to the side, it doesn't matter which one you use. See, these knockouts come right out. Okay, now, it won't take us very long to get all this stuff in. And you'll have this video, I'm going to upload it on YouTube. Can't get my fingers to work, it's Friday. Now, if you have trouble getting it tight, okay, then move that lock nut around till you can get it tight, because now, see, that's tight. You can't not get it tight. We're electricians. Whose job is it to make sure these are tight? Seriously, whose job is it gonna be, you know? It's our job. And if we leave and they're not tight, if all our boxes, if all our connectors are not tight, then it's our fault. Now, I don't think I told you the reason why we have to bond everything. You have two kinds of current. You have fault current and working current. Working current is what makes the lights come on, makes motors turn, makes your stove hot, makes your air conditioner work. It does work. Fault current is when your hot conductor shorts out, either to neutral or to ground. And because the public can touch metal parts, you walk up to your refrigerator all the time. I know it's painted, but it's metal. Your stove, cook stove's metal. Your microwave has metal on it. Your washer dryer, your water heater, all that stuff has metal on it. All that has to be bonded and grounded and taken back to your electrical panel, so that if any hot wire, this is black, this is going to be our hot for 120 volt circuit. If that touches that at any time, whenever it's energized, fault current's going out the roof and it's going to trip your breaker or blow your fuse to keep from electrocuting the public. That's why we have to bond, okay? So let me get the rest of these connectors in here. And if you're doing this along with me, okay, that much the better. Now, whenever it's finger tight, I want just about 70 or 80 degrees to turn. And now, see, it's tight. Goes in quick. Okay, and sometimes you can turn it 90 degrees, okay, there you go, okay, and that one's stuck. There we go, got it unstuck. Okay, this is my last connector. And electricians, what we have to do, we have to pay attention to everything. Everything is important. I've had people say, well, why are you doing it like that? Because nobody can see it, you're gonna put a cover on it. Okay, that didn't tighten up, so I gotta turn it back. There we go. Now, they're all tight. Now, we have all our connectors in there. All our boxes are straight with the board. Nice looking job. Okay, I'm not bragging about me. It's just the way I was taught to do it. It's how I want you to do yours. Okay. All the boxes are tied on the board. I've got extra screws in there. If you need an extra screw or something in a box to get it tight, then put it in there. You know, it's your work. Do it the best you can do it. Okay. And then you got something to sell. Anybody can do sloppy work. But if you do good, neat work, you got something to sell, okay? Now, we are going to use this flexible cord that looks like extension cord, all right? Now, this here has a designation, and the designation is SJ. The SJ means it's rubber, and it's 14 gauge, 3 conductor, okay? Just like a regular extension cord. It's got black, white, and green in it, and it's stranded wire. The other Romex wire will be solid that we'll use in here. SO cord is about twice this diameter, but it has a 600 volt rating, and that's what you make 480 volt extension cords up with in plants, okay, miles of it. So this here, what we're going to do is we're going to strip off enough to get it in this, to put it in that first box. I'm going to show you how to strip it. Now, I know some of you guys have razor blade knives. Now, maybe you're good enough to use them, but I don't know many electricians that are. I know a whole lot of electricians that cut into the insulation and damage the insulation, and it winds up causing trouble. Now, as electricians, we spend our whole lives taking care of insulation. If you don't have good insulation, you know what you got? Scrap copper. That's what you got. And then you're going to have to change it out. You're either going to have to pull it out of the conduit, pull it out of the house, pull new in, okay? So we get real picky with our wire for that reason, okay? A razor blade knife, you can't feel the resistance, so it's hard to know how deep you're cutting. Now, I know some of you guys think, well, you know, you don't know me, I'm pretty good at it. Well, go ahead, you know, but I'm telling you, I don't know any really that can use a razor blade. I know there's some out there, but I'm gonna show you the best way I have found to cut insulation and not damage the wire, okay? So, this here is a rubber jacket. Now what we're going to have 6 inches of free conductor inside those 4 square boxes. That's what the code says. Now, the code is a minimum code. So, I personally want 8 inches in there. If you go to work for somebody, they just want 6, okay? Because every inch of wire costs them money. That's fine, I respect that. Do what the guy's writing your check. You know, if he's signing your check and he wants 6 inches, he or she, put 6 inches in the box. Nothing wrong with it. But I like 8 because I hate short wire, okay? So Marty wants 8. Now, there's 8 inches. Now you can go the rest of your life measuring 8 inches or 6 inches. But what's really good to do is measure the palm of your hand. Okay? I know if I come back here to my wrist lines, that's 8 inches, okay? From the tip of my fingers to where my lifelines all come together, 6, okay? So instead of getting stinking rule all the time, okay? If I just put the wire up like that, and I know right there's 8 inches, okay? Little trick, huh? Now, these are diagonal cutters. I like these. These are Kleins, okay? These are Kleins. They got a little bend to them, and I like that because I can get down against something and it keeps my hands turned up away from the box, okay? Now what I'm gonna do, I'm gonna show you. I'm gonna barely pinch the outside. I can feel that. I can feel that with this. I couldn't feel that with a razor blade knife. Now, if you want to use a razor blade knife, that's fine, okay? But you're gonna have to check it and show me pictures, okay? Now, I barely pulled that apart because I just went around pinching it, and now if I pull it, it'll come off. There's 8 inches, free conductor. Now you can skate the outside if it wrinkles up. Now, what you've got in here are pieces of paper or cardboard, whatever you want to call it, that's in with those conductors. You want to pull them back, okay, and go and pull, put it right on the, put your cutters right there on the side, pull and cut. Now, see how nice that looks, okay? You can cut that off now. There you go. So we got 8 inches of free conductor, okay? Now, on, that's how you strip this cable. Now, the first thing we're gonna do is put our plug on. And here's why I wanna do it. There's a right end and a wrong end. Now, I can use either end, but if you notice, they're twisted, okay? Male and female plugs. Okay, this is the male plug. It's got the blades coming out of it. On a regular extension cord, if you get the right end of SJ cord, all 3 of these conductors, if I pull them out, the way they come out of this cable, green is on the bottom, white is on the right, black is on the left, okay? So, if I turn this down to where green is married up to the green wire, I look up here and my white and black are on the wrong side. So if I hook them up to this, I'm gonna have to cross them to make them work, okay? See, I'm gonna have to cross them. They come out like this, okay? But on this end, I'm gonna have to cross them. Not a big deal, but it's a pain in the butt. Now, if I take this cord, go the other end, all right? Now, I'm not gonna get 8 inches because I don't need 8 inches, but I'm gonna come back a couple inches so I can show you what I'm talking about. Now, I'm gonna pinch the outside. You can feel it pinch the outside. I'm not cutting any inner conductors there, okay? And then I'm putting it in my jaws, barely squeezing it and pulling, okay? See it pull apart? Just that easy, okay? Now, I'm gonna cut these pieces of paper off. You know, just grab them, put it between your dikes, your diagonal cutters, pull. Now, see there how nice that is? Now we've got green, we've got white, now black's on my side. Well, guess what? Now, green on the bottom, they go straight in. White on this side, black on this side, okay? Your brass will be black, your green goes to the green screw, and your silver is what your white wire hooks to, okay? So by going to the other end of the cord, this goes straight into your connector and you don't have to cross your wires. So you know we can work smart or work hard, and this is working smart, okay? So there is a right and wrong way or right or wrong end to get on making up an extension cord, okay? Now, this right here, we'll show you how to make this up. Now, what you want to do is you want to push that back. This is a strain relief, okay? This is going to be a 90-degree male 120 volt extension cord end, okay? Or plug. So the cable's going to come out with my finger instead of out the back. So we're going to pull this off and we're going to thread this through this hole. So you may have to back the screws off, all right? Now, what we'll want to do is we'll want these wires pretty short whenever they come out of the back here, okay? So the first wire we're going to put in will be green. So I'm going to measure here, right like that, okay? And I can see that if I cut this wire right here, okay? I know it looks short, but we got plenty more wire. We can strip back. Now, you want to get your strippers in the right gauge, okay? This is 14 gauge. See how easy that was? I don't want to see you sawing on wire. I'm going to do another video on stripping wire later, but right now, don't want you sawing on it. You know, you're cutting conductors. And our ampacity of that wire depends on every strand being there, okay? And if we cut strands, we're supposed to cut that end of the cable off and re-strip it, all right? So I'm gonna put it in the ground. Green goes to green, okay? Now, I'm gonna tighten this up. Now, they're not lug nuts on F350, but, okay? Tighten and tug, tighten and tug. Now, that looks good, right? Now, see how they line up? I don't have to cross them. So now I'm going to measure this one and cut this, all right? Now, if you look at how wide this block is here that you're screwing down into it, it's about like that, okay? Now, I didn't cut any wire, Now, after you strip it, you want to twist it the same way it's twisted inside. When you strip it, there's a natural twist to it, see it? You want to twist it after you strip it on that natural twist, okay? Now, I'm going to slide this in, okay, right like that, okay? And then tighten my block down. And you can feel when you get it tight enough. You know, now, tug on it. It ain't coming out. I got it tight enough. You got to develop a feel for it. Now, this wire goes straight up into the silver. So remember, green to green, black to brass, and white to silver, okay? Now, I'm going to measure that. And right there's where I need to cut it. Right there, where I need to strip it. Now, natural twist, okay, natural twist. I'm going to go and twist it again, get it tighter. Now I'm going to slide it in here. And I want the insulation up inside the collar of the back, see? I don't want a bunch of stripped wire out here. I want that insulation up inside here. That's the way they're made to do. And that's good workmanship, you know? Use good workmanship. That's what we're gonna learn in this class. If you're gonna slop it together, you ain't gonna work for me or a whole lot of other people, right? Now, you're gonna slide it up in here, and what we're gonna do, you got to get the screw working. It's a little bit aggravating, but you can do it. Now, once you start on it, now, you want to get it straight up and down. You want to get it straight up and down here so it'll go back in the keyway, okay? There's a key in there that it'll fit. There we go. Okay. These are a little more ornery to make up than a regular one, but what the heck. You need the experience, okay? So, having a little bit of trouble there. Let's see what it is. We'll get it. Okay, there we go. There we go. I didn't see it. A wire, I had both wires on one side of the screw, and you want one wire on one side of the screw and one on the other for here on the back. So that was my fault, talking and not paying attention. But we got it straight, and I looked at the wire. I didn't damage the insulation. Had I damaged the insulation, we'd be redoing the plug, but I didn't. Okay, there you go. See how this is all nice up there straight? Okay, now, this is a strain relief to keep you from yanking the wires out. We want to tighten this up, but it's not lug nuts on an F350, okay? We want to snug it. So we're going to snug this up. Both screws. And pay attention whenever you get close. Okay, takes a little more. Good. Now, see there? Now, that is how you make up a 90-degree, 120-volt male plug, okay? And all this is seated properly between the white nylon and the black case. The strain relief is screwed down right. It's not too tight. You can squeeze this so tight that you're going to mash the wire on the inside. When you plug it in, it's going to go pow. It's going to short out. So all you need is just snug. It's just, that strain relief's just to snug, okay? So now we're going to go back over here. And remember, code says 6 inches. I want 8 inches. Marty wants 8 inches. So remember, use your hand, measure, okay? That goes back here, I got plenty. Now, I'm gonna thread that through. This is the end of the board that has the extra 2 inches, okay? Now the reason I'm doing this is in case you drop your board, okay? In case you're carrying your board and you drop it, you've got that 2 or 3 inches here that's not gonna mash your SJ cord on your connector and short it out, okay? So it's a little bit of a guard, intentionally. Now, when you get that in there, inside here is where this black outer part is called a sheath, S-H-E-A-T-H. You want between an 1/8 and a 1/4 inch sheath, undamaged sheath inside this connector. So I like a 1/4 inch, okay? 1/4 inch is just about the width of my little fingernail. So if I've got the width of that little fingernail up inside that box of the outer sheath, I'm good. So now, you may notice some of these have funny looking heads. I'm going to show you why. This is a Greenlee 9-in-1 screwdriver. They make Sapwire, Klein, they all make them now. But you have square shank tips. I love them. Square shank does not slide off. You put it right on there, you don't have to worry too much about it. Now, here, they're not lug nuts on the F350. I know I'm running that in the ground, but you'll remember it. Do not tighten it up too tight. Just tighten it up where you can't freely pull it out, okay? Now, we're good, okay? One last step, okay? One last step. These humps in this box, I'm gonna show you. Get it up here real close. This hump is where you put your bonding screw or bonding jumper. So our wiring coming up to this is all gonna have a ground in it. It's gonna have a bare ground in our Romex, and it's gonna have, we're gonna have that green ground in that plug-in pigtail. So we have special jumpers in your kits, a bonding jumper. That's what this is. That's got a 1032 screw, or no, that's an 832 screw and about 6 inches of number 14 solid. And we're gonna screw that screw right into here, okay? So what you do, now you can take your 9-in-1 screwdriver, if you can find the right, right nut driver, okay? Nut driver, set that screw into that hump, and see that's got a hump so that when you mount it flush, when we mount this to this board, that's called mounting it flush. Now, right here, you want this wire to be, when it comes off that screw head, you want it to be next to the corner or the side of this box, okay? So instead of coming out in the center, make it come out to one of these sides. The reason for that is the center of this, there's only so much real estate in this box, or cubic inches, okay? There's 21 cubic inches inside a 4 square by 1.5 inch box. That 21 inches, we've got to get a device in there. We've got to get a switch in there, a receptacle in there, whatever it is we're putting in this box, plus all our wiring. So the more we can stay to the outside with a lot of our wiring, especially our grounds, the better off we are. So, okay, we're going to put a ground in every box. Let's show you here. Now you always turn it clockwise, okay? Now, there we go. That one's stripped out. So we got another one here. If it strips out, get you another one. Well, that one's stripped out. I'm gonna have to drill and tap that or get me another box. If you have one that strips out, let me know, I'll get you another box, okay? Because one thing we can't do is we can't leave it. Can't leave it, we've gotta have a good bond in there, good ground. Okay, this has got us started, all right? Now, starting Wednesday, we will, and no class Monday, right? Starting Wednesday, in our next class, we will put our Romex in here, okay? 14.2 Romex. We'll start building our circuits. We're going to talk about schematics, wiring diagrams, and blueprints, okay? So, if you have any questions, give me a call. If you need anything, let me know. Other than that, stay healthy, stay well.